Philip Anagram. Given two strings x and t, return true if t is an anagram of x and false otherwise. Okay, anagram is we check the count of the characters in the strings. Now there's a 3a, right, and then 1n, 1g, 1r, 1m. So t is also the same count with the same counts of the characters from x. N is 1, a is 3, g is 1, r is 1, m is 1. So we need to return true. This one is false because r is 1, a is 1, the same. Here t is 1, but here t is 0, right? So we need to return false. Basically, we need to check their length first, right? Okay, so if their length are not the same, we can simply return no. Hey, this is not the anagram, right? We can their counsel cannot be the same, right? Cannot be equal. It's okay. False. Okay, if they are having same length, what we are gonna do? Okay, so normally we will sort, right? We will do sorting, character by character in one string, and then we will sort S, and then we will solve T, and then we will check every character in the specific index are the same, and then if they are the same, we can say it is an anagram. If not, we can say it is not an anagram. We will return false value, right? So it is easy. We will sort, and we will check every elements in the specific index, right? So when we are thinking about the time complexity, because we do sorting, that's why minimum is order of n log n, right? So I want to reduce that one, so I'm gonna use the hash map because I will mark how the count of each element in the first strings, and then I will count every element in the second strings. When I am doing the first strings, when I am taking the count values of the every characters in string S, I will plus to that hash value. But when I'm doing T, I will do minus value. So every values in the hash table keep its value in every value. If every value is 0, we can think that one is the anagram, right? Each other. So if it's not, we can say no, it's not. So we can reduce from the order of n log n to the order of n, but the speed complexity is like the order of n, right? Because we are using the hash map n plus m or something, right? Okay, the length of s plus the length of n, m. Okay, so let's do it. I'm gonna create the hash. We can use the dictionary and hash table in the C#, right? I'm gonna use the hash table this time. Okay, and then count, and then new hash table. Okay, and then I will loop each values in each character values in string S. Okay, if we will check the value is already in our hash table or not. If count of C, if it is equal null, we will add, right? Count dot add, the key is character and the value is 1 because the very first time. If it is not, we will change that count value at the key C, and then we will plus 1, right? Okay, when we are using the dictionary, it will not give us null value, it will give the exception, we will get the error. That's why I just use the hash table. But if we can handle the exception, it's okay. This only depends on our logic, right? So okay, let's do this one again. For the T, right? If it is null, we will add to our hash table. If it is not null, we will minus. And then we will check for the final values, right? Character, because the key, we will get the key from the count hash table, and then if the integer value count at the key value, key index, if it is not equal 0, we will return false. If it is not, return true. Oh my goodness, TU is true. Okay, let's do this. Okay, count. See, okay, here, because it will return object value, so we need to return to the int values, right? We need to cast the data type. Okay, here -1. Oh, sorry, I need to cast this one too. Okay, cool. I'm gonna submit this one. Awesome. Okay, so that's it. Thank you.